Anytime you check your weight on a scale, or you're measuring something, or you're measuring the length of a ruler, or you're measuring the volume, you're measuring a quantity. And if you're measuring a quantity, you have to report a unit. What it means is each measurement has or is composed of a number and a unit. Now, in United States, most measurements are made with the English system using units like miles, gallons, pounds. Now, a disadvantage of this system is that you cannot just convert one unit to another uh, using some kind of system. You pretty much you need to memorize it. For example, if you want to convert pounds to ounce, pounds and ounces both are units under the English system, and 1 pound equals to 16 ounce. Or if you're converting gallons to quarts, then 1 gallon equals to 4 quarts. Or 1 mile equals to 5280 feet. There is no system here. They are not systematically related. So you have to memorize these. But in the metric system, and in fact, scientists, health professionals, and people in most other countries, they use the metric system. And the beauty about this system is that you can go from one unit to another by just following a system. What it means, so because in metric system, each type of measurement has a base unit, and all other units are related to the base unit by a prefix that indicates if the unit is larger or smaller than the base unit. So let's look at this mnemonic device, and once you're going to understand this mnemonic device, I'm pretty sure you'll be able to do all the problems. King Henry does not usually drink cold milk. You're not gonna believe that I learned that from my daughter who's in the elementary school. K stands for kilo. Let me show it one more time here. So this K stands for, here this K stands for kilo, H for hecto, D is deca. This U is unit, and that unit can be like meter, gram, or liter. D deci, C centi, and this M milli. So for example, let's say you are given 5 kilometers and you have to change it to meters. Now where is kilo? Kilo is here. Where is meter? Is here, the base unit. And what we're going to do is, from kilo to meters, you're going in a forward direction. And you're making from kilo to meters, you're making 3 jumps. 3 jumps in the forward direction means multiplying it by 1000, because from here to here is multiplied by 10, from here to here multiply by 10, from here to here multiply by 10. So 5 kilometers equals to 5, and then you put 3 zeros, 5000 meter. On the other hand, let's say you have 10 you have 10 hectograms. 10 hectograms equals to how many decigrams? How many decigrams? So here, now for deci, we only use dg for, so that's why we can say 10 hg equals to how many um, decigrams. Now, so again, where is hecto? Hecto is here. Where is deci? It's here. Again, you're going in a forward direction. How many jumps? 1, 2, 3 jumps. So that means 10 hectogram. So first you have to put this number. How many zeros? 1, 2, 3. 10 decigrams. On the other hand, when you're going in a backward direction, in the reverse direction, are you still going to multiply it? No, you're going to divide it. For example, let's say you have 10 centigrams. How many are centigrams? How many are just grams? Let's say. So where is centi? Centi is here, and where is grams? Is here. And you are going from centi to grams, 1, 2. 2 places in a backward direction. So again write down 2, 10, the number. But now instead of multiplying, you're dividing it with 100. Why 100? Because you move 2 places back. And for each place is 1 0. And what is 10 divided by 100? It is 0.1 gram. So keep in the mind, you go in the forward direction, you multiply, you go in the backward. The next one is the significant figures. This is a very important topic. Uh, there are two types of numbers, exact numbers and inexact numbers. Exact numbers is that you get it from counting. 10 students, 10 apples. But inexact numbers is that comes from the measurement. For example, you're measuring the length of a ruler. One student can say 5.6, another one can say 5.7. So there is an uncertainty in the last digit. So significant figures are all the digits in the number, including one estimated digit. The rules are significant figure rules. First, all non-zero digits are significant. So let's say how many significant digits are in this number? 623. So there are 3 significant digits here. A zero is significant only if it occurs between two non-zero numbers. For example, let's say 603. Is this zero significant? Yes. So how many significant figures are in this number? Again 3. Zero at the end. 0 at the end is significant only if there is a decimal in the number. Otherwise, it's not significant. So right now we have 3 significant figures here. But if I write it down simply like that and no decimal in the number, then it's going to have only 2 significant figures. And that decimal can be anywhere. For example, if it is like this trailing 0 at the end is significant as long as there is a decimal in the number. Leading zeros, on the other hand, what are leading zeros? Zeros at the starting. These zeros are not significant, even though there is a decimal, but since these are leading zeros, zeros at the very starting, these are not significant. So how many significant figures then will be in this number? Only 2. How to apply these significant figure rules in multiplication and division? Let's say you're multiplying 10.0 with 5.0. 10 times 5 is 50. There are 3 significant figures in this number. There are 2 significant figures in this number, and you go by the fewest one. So the answer should have 2 significant figures. To report 50 in 2 significant figures, we have to put decimal here to make this 0 significant. In adding or subtracting, what we do, let's say 2.46 minus 1.2. You look at the digits after the decimal. There are 2 numbers after the decimal here. There is 1 number after the decimal here. So when you subtract, you're going to have only 1 number after the decimal. So the answer will be 1.3. Why 1.3? Because because this 6 here is if this number here, the one we are ignoring, is 5 or more than 5, then we increment the last number by 1. So that's why it becomes 1.3. And addition and subtraction both follow the same rules.
Made with Doodlecast Pro.